Maybe we don't need this. Okay, so this is what I plan to do today. Number one. Okay, everybody ready? So number one, I just want to run over the stuff we did yesterday, and we're going to move it along just a little bit by talking about object references and how you keep track of, how you kind of link objects up together. How you say this object has this other object as a field, and what does that actually mean? The other thing then I would like to do today is to talk, because somebody posted on the tutorial thing, to maybe just go through the solution to last week's lab, which was the strings in C# lab. So I'll do that today. Okay, and your lab class this week is all to do with strings and objects and arrays. So you need to know last week's lab and understand the solution, but also understand the objects and the references and things we're doing today. So we did loads of definitions yesterday at the start of the class, but we won't go through them all today. I'm sure half of them you won't remember, but until we actually do examples of them. But a few of the ones from yesterday that are kind of important. So the first one that we talked about is a class. Can anyone tell me what's a class? It's number one, it's a type. Number two, it's a template for an object, isn't it? What do classes contain? Fields, and what else? Methods. Yeah, so classes contain fields and methods. What's a field? It's data. It's a variable. Alright, so a field is just a variable. And what's a method? It's a function. It's what we would have called a function in C. So a field is what an object is, and a method is what an object does. Alright, so then we talked about there being this thing called an object. What's an object? Exactly. An application of a class, a better way to say, is an instance of a class. So while a class is a type, an object is the instance, or it's the variable, which is the type. All right. So if you think of int I, int is the type, I is the variable. You can't assign to int. Sure, you can't. You can't say int equals 5. You have to go I equals 5. How do you get access to the fields in an instance of a class? You use dot. Alright, so if your class is called, if your instance is called Misty, the dog, you go Misty dot name, and that gets access to the name field in the Misty instance of the dog class. Is that alright with everybody? So if you need to write any notes on that, you should write your notes on those particular topics, because they're really fundamental. When we're talking about this whole thing of classes, we said that there was 3 pillars to OO. This is the first pillar. What's it called? Encapsulation. So why do you think it's called encapsulation? What does encapsulation mean? Containing something. So what are we containing? The data and the methods. So that's what encapsulation is about. It's about getting the data and the methods together into a thing called a class. That's why it's called encapsulation, because you encapsulate the data for the object, and you encapsulate the behavior of the object inside a thing called a class. So yeah, what else we talked about? We talked about constructors. What's a constructor? Anybody? Constructor. It's a method, right? Somebody else, you guys sitting up at the back, why don't you come down here? Because I think you're a little distracted. Come down here and make more of a contribution. I know all this. I don't need to learn it again. You guys need to learn it. Come on down to the front, will you? Will you come down to the front? So there's this thing we said called a constructor. And a constructor is what? It's a method. And when does it get called? Just be careful of the camera there, will you? The constructor gets called when an object is created. What about a destructor? When does that get called? When the object is destroyed. When a goes out of scope. Yeah, when the object is no longer required, it goes out of scope. The destructor is called. All right. So make sure you know all of those. They're very fundamental definitions. If you were asked any of those questions in an exam or in an interview and you got them wrong, what would happen? In the exam, you'd get 0 because they're really fundamental. You know, you can't progress on this course unless you're clear about what all of those things mean. Unless you just even can repeat the definitions and understand what they refer to. And in an interview, they're really fundamental questions. You know, you wouldn't get anywhere in an interview if they asked you what's a constructor. Give me an example of when you use one, and you couldn't answer that. I mean, you wouldn't get any further in the interview. That would be the end, and you could go back to working in Spar or somewhere like that, right? Because you certainly wouldn't get a job as a programmer without knowing any of those things. They're really fundamental. All right. Okay, so we'll do another example today. Yeah, let's get this thing going. So this is the program that we worked on yesterday. Now, a couple of things. What's the significance of the name of this class and the file that it's in? They're the same, okay? And typically for classes, do we start with an uppercase character or a lowercase character? Uppercase. So the class is always begins with an uppercase character. Is that part of the C# language? It's not enforced in the C# language. So it's what we call the coding standard. So the standard in C# is that you start your class names with an uppercase character. What about these things here? What are they? Hello? Fields. These are the fields. All right. What's this method here? It's the constructor, isn't it? Guys, you need to wake up a bit here, right? This is the constructor. So I'm assigning the fields to be 0 and the empty string and the empty string. What's this method here? Yeah.
Here, did you not say that the...
Call me Brian.
Brian, did you not say that it will default it to empty anyway if you don't put in that? So why...
No. In C#, right? Sometimes it will default to empty, but a lot of times, if you, for example, try and print this without initializing it to be empty, you could possibly get a runtime error. And I'll show you how you can generate one of those today. You'll get something like a null pointer. It'll say you're trying to use this variable without putting a value in it. So the compiler in C# is much better at detecting those situations. When we did C programs last year, what would happen if you tried to print an integer without initially putting something into the int? You would get a random value. You know, it's just whatever happens to be in the computer's memory. In C#, if you try and print this variable age without putting something in it, first of all, it will tell you that the variable is unassigned. But if by chance the C# compiler doesn't catch that and allows you to run your program regardless, it will have the value 0. But anyway, it's just kind of important in your programs to think about the initial values for things and to put initial values in. That will be a very typical default constructor. Alright, just initializing all the variables to be 0. So this is an example of another constructor. When I have two constructors or two methods with the same name and different parameters, what do we call that? We call that overloading. So that's an overloaded constructor. There's two different versions of the constructor, and it will call this one if I create the object with no parameters, and it will call this one if I create the object passing in an age and 2 strings. What's the purpose of this?
One that you're calling at that time.
Exactly, it's the current object. But why do I need it? Exactly, yeah. What's that term called in programming? Disambiguate. So if you think of the word ambiguous, ambiguous means what? Unclear. Alright? So if you went age equals age, it would be unclear if you're talking about this age or this age. So you disambiguate by using this to say this is the current object's age, and this is the parameter that I'm passing in age. And what's this an example of here? Public void bark. That's an example of just calling a method. Alright, so that's my class. Over here in program, we have one method here which is the main method, and this is a static method. So what does a static method mean? Again, look at the definition if you need to, but this should be, in an interview situation, if you were asked this, you'd need to just say it straight off, and it would need to be kind of part of your vocabulary. It's part of the vocabularies of a programmer. So what does static mean?
You're able to call the method without having any data or something in it.
Without having an instance is the word you're looking for there. So you can call this method without there having to be an instance. So I'll give you an example of one, right? Let's say that, and this is probably not a good thing to do. Let's say that all dogs have 4 legs. Is that the case? Probably not, but most dogs have 4 legs, right? And I'll show you, this is why statics are kind of slightly dangerous, because you might make an assumption that all dogs have got 4 legs. So you can do something like this. Static int num, Static int num legs equals 4. Alright, so now it says this dot name says woof woof. Alright, let's put something else in here. I have num legs. Okay. Oops, forget about the quote there. Alright, num legs. You notice that over here in program.cs, right? I've set up Dory and I've set up Misty. Dory has got age 3, name, breed, etc. Misty is age, breed, name. I haven't ever set the number of legs. Alright? But watch what happens when I run this program. There's Mr. T as well, so I'm going to zoom out here. I'll run this program. Okay, they all have 4 legs. Do you see that? Do you now see how the static works? All of them get the same value. Alright, watch what happens here. Watch this. Did I not make that public? I need to make it public. Public static num legs. Alright. Dory.num legs equals 3. Okay. Alright. The reason why we're getting this error, some programming languages will let you do this, but C# won't let you do this. C# says that num legs doesn't apply to the dog Dory, but it applies to all dogs. So what you can do is you can do dog.num legs equals 3. So you refer to it via the class. Now what's going to happen? All the dogs have 3 legs now. Because we've just said all dogs have 3 legs. That's what a static is. Do you understand? Is that alright with everybody? Happy so far? Does everybody know what a class is, what an object is, how you create one, how you call methods? Hello? Good. Alright. Let's make another class, just to get some practice at it. This time, let's make a class. Oh, by the way, I'm sure something you were all wondering about yesterday. There must have been one question you were all going home wondering about, wasn't there? No? What does Misty look like? That's what Misty looks like. So that's why I run home in the evening times. Instead of staying around here working on the labs, I run home to see if Misty's okay. Look at that. How can you leave that in the morning times? Anyway. Right. So let's make another class, just for some practice at making classes. Right. Let's add a new item here. A class. This time let's make a cat class. Right. So again, we'll use cat with an uppercase C. Click on add Now I have my cat class. What do cats have? Huh? Cats have 9 lives, don't they? So let's make a couple of things for this cat. Let's give it a string. Public. Public. So cats also have 9 lives, right? So num lives. And then let's make our constructor for the cat. So how many lives does a cat have when it starts? So numleg starts out with 9 when you create a cat. Let's make a method on this cat, right? What happens when the cat dies? It loses a life. Numlegs minus minus. Now, cats can't have negative lives, I guess. Sure, they can't. So the cat can only die if it still has some life left. How would we do that? What would we use in C# to check to see if there's still some lives left? An if statement. If num lives is greater than 0, we can subtract 1 from the number of lives. And we might as well also put in a boolean here. Is alive. So then, when the cat is created, we can set is alive to be true. And otherwise, so subtracting 1 from the number of lives, in fact, let's do this the right way. Subtract 1 from the number of lives, and then we can say if num lives is equals to 0, is alive is equals to false. Alright, so I now have a cat class. My cat has got a name, it has a number of lives, it can be alive or dead. You can check the is alive boolean to see if the cat is alive or dead. Every time the cat dies, it loses a life, and then once the number of lives reaches to 0, the is alive is set to be false. Alright, let's jump over to our program here, and now we'll create a cat. Who's got a cat? What's your cat called? Theo! We'll shorten it to Theo, right? Because Theodore is too long to write. Theo equals new cat. Theo.name equals Theodore, is it? Is that the way you spell Theodore? Alright, so this cat has got 9 lives, right? Let's jump over to our cat class again and do something with the cat class. Let's get it to print stuff. What did we get this guy? Oh yeah, what do cats do when they speak? This one barks. Let's make this cat say meow. How do you spell meow? How do you spell meow? M-E-O-W. Okay. So the cat says meow meow, and then it says, oh hang on. An interesting thing has just occurred. We need to modify this program somewhat. Cats can only say meow meow if what? If they're alive. If is alive, the cat can say meow meow. What do dead cats say? Okay, how about that? Okay, so the cat either says meow meow or it says I'm dead. So if it's alive, it'll say meow meow. If it's dead, it doesn't say meow meow. It just says I'm dead. So now, you're not going to like this. We're going to kill Theodore. All right. Theo.meow. Alright, so we'll say Theo.meow. So then we have to kill Theo 9 times. Theo.die. How do I kill Theo 9 times? What's the programmer's way to do that? Inside a for loop. Wouldn't that be better? For int I equals 0, semicolon, I is less than... Yep, to do it 9 times, I is less than 9, because that will go from 0 up as far as 8. As soon as I becomes 9, it jumps out of the loop. Yeah, because we're starting at 0 going up as far as 9. Just counting 9 times, right? Equally, you could do for I equals 9, I is greater than or equals to 0, I minus minus, and that would do the same thing.
You do it while it's alive.
Oh, that's a good idea as well. Right, let's do that one. I like that one even more. That's better, isn't it? While Theodot is alive, we call the die. And every time we call the die, the number of lives gets decremented by 1. As soon as the number of lives reaches 0, the is alive becomes false. And so this while loop finishes. That's a better way to do it, isn't it? Right, let's get rid of this way. And we'll set a breakpoint and we'll run this program. And see what happens. Let me just put something into this die thing here. Console.writeLine. What do cats say when they die? I think ouch.
Don't kill me.
Again.
No cats were harmed in the creation of this program. Alright, so the cat says ouch, and it says how many lives are left. Right, let's debug our program. So let's set a breakpoint here by pressing F9. Then I'm going to press F5 to run the program in the debugger. So we create our cat Theo, and I'm going to press F11. F11 means what? Step into in Visual Studio. So it steps into the constructor. And you can see it's setting num lives equals to 9, and is alive is equals to true at this point. Okay, so cat.name equals Theodore. So cat.meow, we're going to press F11 so we can see it stepping into this method. So if is alive, so is alive is true, yeah, because its number of lives is 9, and we set is alive to be true in the constructor, and then I'm going to print out meow, meow, meow. Alright, so we reached the end of that statement there. While Theo.is is alive, we're going to do Theo.die. So let's press F11 into this. So my number of lives at this stage, what's it going to be? So is 9 greater than 0? Yeah. So it comes in here, is alive, number of lives minus minus, prints ouch, number of lives left. So I now have 8 lives left. Number of lives is equals to, it's not equals to 0, so is alive is still true. So then I call die again. Over and over again. This is horrible to watch this. Poor cat. This is pure cruelty. Look at that. I have 3 legs. Meow meow. So already we've actually chopped a leg off a dog and we're killing a cat. We've actually chopped a leg off all dogs. So let's hit F5 to run the program to its completion, and eventually it gets down as far as 0 lives left, and then the cat is dead. Alright. So that's classes. Is everybody happy with that? Does everybody understand what we've done? We move on a little bit. Everybody knows what a class is, what an object is, what fields are, what methods are. Alright, let's do something else. Just for fun, I am going to open up a new instance of Visual Studio here, and I'm going to do something really quickly in your favorite programming language, apart from C#, C. Alright, just something really quick, just to show you the difference between C# and C. So I'm going to create a new C project here. I'm going to add a new C++ file here. Alright, in here, let's put the bare minimum C program together, just so I can demonstrate this thing. Hash include standard io.h void main. Alright. Now, I want to make a struct. How do we make a struct in C? Type def. We give the struct a name. What should we do struct? Let's do a dog struct. Alright. Now I'm going to make this a really easy dog struct. I'm not even going to bother including the name in here. I'm just going to include the dog's age. So we've got type def struct dog age, put a semicolon like this. You can then make instances of that struct by going dog. Let's keep it Misty and what was the other dog called?
Dory.
Dory, right? Noticing in C we don't have to go equals new dog or anything like that. So DORI. Now watch what happens here. Misty dot age equals 10. Oh no, Misty's 3, right? What age was Dory? Dory.age. Dory was 3 as well, was it? Let's make Dory 4 for this example here. Everybody alright with this so far? Not too complicated. This is just a struct in C with one element in it. Now, let's do something interesting here. Let's go Misty equals Dory. Oh. D-O-R-I. That's not going to compile then. Misty equals Dory. Misty.age equals 6. Printf %d /n comma Dory dot age DORI. Thank you. Now let's take a look at what we're doing here in this program. Okay. Dog Misty. So that's created a struct, which is Misty. It's got one element in it called age. We've got dog Dory, so you can go Dory.age and Misty.age. I've got Misty.age is equals to 3, Dory.age is equals to 4. Everything's okay up until that point, right? If you were to print out Misty.age at this line here, you'd get 3, and if you were to print out Dory.age at this line, you would get 4, wouldn't you? So then I go Misty equals Dory. Alright? And then Misty.age equals 6. So I am changing Misty's age. But I've previously gone Misty equals Dory. Over here, if I now go Dory.age, what's it going to print? 4 or 6? I hope I've done this right. What do we think? Huh? 4 and 6. Misty equals Dory. Misty.age equals 6. And then I print out Dory's age. So what I'm wondering here is Misty changed or is Dory changed? Yeah, actually now that I think about it, this is what I wanted to do, right? Yep. So what's going to happen? Is Dory going to be 6 or is Dory going to be 3? Or Dory's going to be 4? So what do we think? 4? How many people say 4? How many people say 6? How many people say 3? Just for fun. Right, let's run it and see what happens. hit F9 at that point, run my program. Yeah, I want to run it. Okay, F10, what gets printed out? Dory's age is still 4. Dory's age is still 4. So what have we learned? When you do an equals like this with a struct in C, what is this telling us about how equals and how structs in C work? What is it telling us?
One side takes the value of the other.
One side takes the value of the other. Normally that is what happens, right? And in fact that kind of is what happens. But this is more complicated because this is a struct. You know, this could have loads of data in there. This could have loads of ints, it could have arrays, it could have car stars, everything. Yeah.
You say that Misty equals to Dory, not that Dory equals to Misty. So then, if you then change Misty's age, you're not changing Dory's age.
That's the key to it. What's your name again?
Sarah.
Sarah has just uncovered the entire point of this whole thing, right? In this example here, I am taking Dory and I'm copying the entire struct of Dory into the memory that's been allocated to store Misty. So Dory does not get changed when I change Misty. They remain two separate things. There's two separate things. All I've done at this point is I've copied this block of memory over to this block of memory. Alright? So when I change this block of memory, it doesn't change the original thing. It doesn't change Dory. Because they're still two separate things. You follow that? Is everybody 100% clear on that? They're still two separate things. You know? Let us do the same program in C#, right? And we'll stick to, we'll use dogs. Okay, so I have dog Misty and I have dog Dory. Alright, now, let's do something here. Let's do the same thing. We took Misty equals to Dory, didn't we? That's what we did in the previous program. Let's do something here. Dory dot age equals 5. Oops. Misty dot age equals 3. Okay. Dory with an I. Thank you. Keep making the same mistake. Alrighty. Misty dot age equals, what did we change Misty to be? 4, wasn't it? In the other program? Okay, let's change it to be 4. Alright. Console.writeLine. Dory. Oops. Okay. Now looking at this program here, if C# worked the same way as C, we would expect to print out what here? 5, wouldn't we? Yeah. If C# and C work the same way, when you do Dory.age equals 5, Misty.age equals 3, they remain separate, don't they? Everybody following this? Alright, so when I print Misty.age equals 4, I basically changed Misty, but I haven't changed Dory. Isn't that the case? When I print out Dory's age, it's going to print out the age 5. Is everybody following this?
Yeah.
Yep, great. Let's set a breakpoint and see what happens. F9, set my breakpoint. We're not expecting anything. I'm not expecting any surprises here. We're expecting it to print out 4, aren't we? Or to print out 5, I should say. Let's hit F5 here. I'm going to hit F10 to step over this line. Let's look at the console. 5. Oh, hang on, that's the wrong program. That's the other program, I think.
No, that's right. Is it?
Debug. So you run this again. F5. Dory's age is 5, Misty's age is 4. Oh, sorry, I haven't done the important bit. Misty equals Dory. Yeah, okay. Sorry. So, okay, in C when we did this and we printed out Dory's age, we got 5, didn't we?
Yeah.
Alright, let's run this program again in C#. Debug, stop debugging. Let's hit F5, running again. Let's zoom in here again before we check the output of this. We are expecting 5 to get printed out here, aren't we? If 4 gets printed out here, what does that mean? It means it's all wrong. Alright, so let's hit F10.
let's jump into our little program here. 5. Oh my god. What does that mean? That's the same program. Stop debugging. Stop debugging you. That's a previous run of the program. Is that the C program? That's the C program. Everything is now stopped. Let's go back to our C# program. Console application here. Misty equals Dory. I have gone. No. That should be before. Okay. Now we're getting places, right? Dory's age is 5, Misty's age is 3, Misty equals Dory, Misty's age is 4. We're expecting to print Dory.age here, we're expecting Dory to be 5 now. That's it, sorry about the confusion. Everybody ready? F10. Finally, we get the result. We get 4 getting printed out. So everybody look at what's happened here, right? 4 is what got printed out there. Okay, so I've gone Dory.age equals 5, Misty.age equals 3, Misty equals Dory. I have changed Misty's age to be 4, but it has also changed Dory's age. So it's the opposite to C. That took us a while to get there, but we got there in the end. So, does everybody understand what has happened? You don't have to understand why just yet, because I'll explain why that is the case in the C# language. Does everybody understand what's happened? Yeah. I've changed one thing. I made them equal to each other, first of all. I changed one thing, but it also changed the other thing, the opposite to what happens in C. Everybody understand that? Right. Let's explain why that happens in C#, right? When you declare a variable like this, dog D equals new dog, that does 2 things. Number 1 is it goes off to the computer's memory and it allocates a block of storage required to hold 1 dog. Alright, so all the memory required to hold a dog, it goes and creates one like that. What it does when you go D equals new dog is instead of making D equals to the dog itself, what you actually get is a thing in C# called a reference. And a reference is like a label on a piece of luggage. Alright? This is what D is. So it's actually the reference, and this is the idea of a C# reference. So this is what we call a reference. Okay. Then what did we do? In fact, we might as well use the examples here. I did Dory. And then I go dog Misty equals new dog. So what it does then is it goes off and allocates a second dog called Misty, like this. And it makes the, this is basically another dog object over here. And then I have this Misty thing here. So you got Dory and Misty. Alright? You need to take this diagram down, because if you take this diagram down and understand it, you know, it will really clear up this whole idea of references in C#. So this is stage 1, this is 2. So I'm going to put these numbers up there. That's number 1, that's number 2, which is Misty. Line number 3. Okay, when I go, what did we do here? We did Misty equals Dory. Misty equals Dory. What happens is it takes this label, and instead of making a point at the previous one, it actually now makes a point up to this one. So this is stage number 3, and that's what happens. Alrighty, so what happens here, you know, is that you now have this hanging object, this previous one, that nothing now refers to anymore. It's still there in memory, but there's nothing now connected to it. Alright? If you do this code here, Misty equals Dory, and then you go and change Dory, you can see that both Misty and Dory are pointing at the same object. Do you understand? They're pointing at the same object now, because they're both referring to the same object. So when you change one object, it's the same object. It's the same object. What happens to this one? What happens to this one down here? it gets left hanging. And what happens to it eventually? Garbage collection. GC. So this is the way Java and C# work. They work with this garbage collecting thing that looks for these type of objects that are no longer being referred to, and it goes and frees the memory for you. And it runs on what's called a low priority thread. So it's running constantly in the background. It looks to see if your program is idle. If your program is idle, it goes and searches through all the memory that's been allocated and frees up these kind of hanging objects that might be lying around like that. It's different in C++ and it's different in C. Because in C, everything is what's called a value type. That's what the structs are. They're called value types. In C++, you can choose whether to use value types. You can choose whether to use reference types, which are these things. Or, of course, you can also use... What else have we got in C++ that we also have in C? Pointers. So these are kind of like pointers. They just point to the same block of the computer's memory. And that's what a reference is in C#. The cool thing about references is that you can pass references around your program. They're very efficient because it's just like a pointer. It's only telling you where the thing is located. It doesn't actually hold the thing itself. So you can pass them into functions or methods very efficiently. Alright? They just take up the size of a memory address. Alrighty, what are we doing for time? How have we got?
10 minutes.
It's 10 to. Do you want to quickly just have a quick look at last week's lab solution?
Yeah.
The whole point of today was to get you into this idea, which is basically a reference. So when you declare an object and you create an object like this, it creates a reference to the location where the object is stored. And when you change the reference to point to something else, sometimes the old objects get left hanging like that. Alright, and then they get garbage collected. Yeah?
It doesn't matter which one you change, either Misty or Dory, it's going
Yeah.
to change.
Most definitely. The only thing is if you did it the other way around, then it's a different object that's going to get garbage collected. You know, if this was originally 5 and this was originally age 6, you made them both point at this one, then they would both be age 5. Well, the one object will be age 5, but both references point to the same object. If you made them point at this, then they would both be 6. So if you swapped the order in which you did the assignment, it would be the other way around. I hope I haven't over-confused that issue. It's the whole idea of an object reference, which is the way objects are done in C# and in Java. All right. Strings lab. I wonder if this is the one. Oh yeah, here we go. So, yeah, sorry, I haven't put this up just yet, even though the lab is up and everything, I just forgot to put this up, but this will be on the website so you can have a look at it, right? So the things we had to do, oh, by the way, now you can see that index of, what is it? In terms of what we've already covered, it's a method. So you're just calling a method on the string class. String is now a class. When you go string s, the strings are different, by the way. You can do this. You don't have to do equals new string. You can declare a string like that. But a string is just an object, right? The same as everything else. So when you do lolcount, you pass in the string. What I did here is, first of all, set location equals to 0. So I'm starting at the beginning of the string. Then location equals s.index of toFind is the thing I'm looking for, which is basically the string LOL. Starting at location, so it starts at 0 initially. If location is not equals to -1, then that means it's found a match. Alright? And then location equals toFind, so in other words, where it found it. Sorry, location plus equals to, so it takes the location where it found it, the thing you're searching for, and then finds the length of it, and it advances that number of characters into the string. Alright, so if it finds it at character number 5, and I'm looking for a 3-character string, it moves on to character number 8. And then counts plus because it's found a match. Comes back in, does the location equals s.index of again, so it will search for it again, and it continues to search for it until it reaches -1, and then at that stage it just returns the count. I'll get Mark to go through this in the tutorial as well, right? In a little bit, we're running out of time. To do the cipher thing, the most efficient way to do the cipher thing, I wrote this method called cipher, and this is my encrypt and my decrypt in one. So if you notice, they're basically the same thing. One adds 1, one subtracts 1. So I just wrote cipher and I pass in whether I want to add or subtract. So key is going to be either 1 or minus 1. And then what do? I go through message from the last character to the first character. So I go through it in reverse. So I start I is equals to the length of the thing minus 1. Why the length minus 1? Because if it's 5 characters long, then it's from 0 to character number 4. So I want to start at character number 4, go back as far as character number 0, and I is greater than or equal to 0, I minus minus. So I go through the one string from the last character to the first character. I basically add the cipher to it, plus equals to the key, and then I append that to the other string. So I'm just picking the last character from the first string, adding it at the end of the other string like that. And in the process, I'm just adding the cipher to it or not. Is that okay with everybody? So I'll get Mark maybe to spend maybe 20 minutes going through this with you in the tutorial as well, because we're just running out of time now, okay? And then for encrypt, I just call message with 1, and for decrypt, I call message with minus 1. Alrighty. Okay.
Brian,
Yeah.
what about next week?
Oh yeah. Who's your class rep? Paula. Is she here? Will you tell your class rep to send me an email and decide what the class wants to do next week?
We're already in on Tuesday.
Yeah.